Alright, I skipped this problem a while ago because I wanted to go back to it. I wanted to have a little bit more time just to talk about this problem by itself. And before we tackle this, I want to go back to just factoring a number and what really goes on there. So let's just take some number like maybe 120. If I wanted to factor that and factor it all the way down, prime factors, then this is where we created like a factor tree, and we think of two things that multiply together to get 120. Well, it can be any two things that you want it to be, as long as they multiply together to get 120. So maybe let's say like 10 times 12 is 120. Well, now 10 can be factored down some more. So I can continue factoring that down into, 2 times 5? Now 2 cannot be factored down anymore, and 5 cannot be factored down anymore. But we need to look at the 12 also. 12 could be factored into maybe 2 times 6. Our 2 cannot go down any further, but the 6 can. 6 would be 2 times 3. So when we completely factor this into its prime factors where it can't go down any further, then we would have 2 times 5 times 2 times 2 times 3. When we're working with polynomials, we have to keep in mind that same exact concept. We have to factor, and then you have to see if you can factor some more. Because what our goal is to get it down to where they will not go any further. You are at a list of prime factors, something that cannot be broken down any further. So let's look at this this problem. And remember, your very first step in factoring is always to pull out the GCF. So here we have actually a GCF in this problem. We've got a common 2 that we can pull out. So 2 times x squared would give us back to the first term. 2 times negative 4x would give us the second term. 2 times negative 2x would give us the third term. And 2 times a positive 8 would give us the last term of 16. Now 2 is done. It's like over here when we did our factor tree where we found a factor that could not go down any further. So 2 is done. But now we need to look at this polynomial and see if it can factor down anymore. Because there are 4 terms here, we can factor by grouping. That's our technique. So if I look at only the first 2 terms, they have a common x. And so x times x would give us x squared, and x times negative 4 would give us negative 4x. Now, in all of the factor by grouping problems that we've done so far, have you noticed that when we factor something out of the first 2 and the last 2 terms, we need that binomial that's left to be the exact same thing? So I really want to pull something out of these last 2 terms so that my binomial matches, so that it's x minus 4. What times x gives us negative 2x? That would be a negative 2. And does negative 2 times negative 4 equal a positive 8? Absolutely. That's how you check and make sure that you've removed the correct item. Now we have a common x minus 4 that we can pull out of both of those terms. So when I pull it out of the first term, we have left an x. And when we then pull it out or factor it out of the second term, we have minus 2. Now don't forget, up here we had this 2 that we factored out at the very beginning, and we kind of circled it like we did all of these and said, this one's done. But at the very end, we have to write them all as factors, a series of factors. So this is the way that polynomial factors.